arc of the curve is, and if I take half of this, because this is from 0 to this only, and but after taking minus pi, this whole arc is revolve about this. Okay, is rotated about the line theta equal to pi by 2, and the area of the surface. Then okay, this is the answer here. So 43 into 8. Get the value 8 3 are 24, 4 to carry, 8 for the 32 and 3 2, 32 and 2, 34. So 344 upon 15 root 2 into pi a square. This is the answer here. Coming a strange answer. Okay, so answer is this 48 root 2 upon 5, it is coming pi a square. Maybe some mistake, r cos theta ds upon d theta. Okay, it's coming here. So this is the answer, no problem. Okay, root 2, because it is 2 root 2, it can be 2 is also there. It can be further, root 2 can come in the numerator, no problem. It can be there, 48 upon this. And okay, only 8 will be there. Okay, so this is the answer here. It can be further cancelled out by 2. It can be 2 and root 2 can come in the numerator, no problem. This is the answer. Okay, so this is the question number 1. Let me take next question. Second question is of what kind? Let me talk about. Okay, the process I'm just telling about, that how to solve the questions. Now this question was just about the line which is that, or revolve about the line which is at theta equal to pi by 2. Okay, and limits we took from minus pi by 2 to plus pi by 2, because in the lower one it was there. Now let me take next question. Now this is here. Second question. Find the surface of the solid formed by the revolution of the cardioid r equal to a into 1 minus cos. This is again cardioid. That was the cardioid. This is also cardioid. About the line, initial line now. Now it is initial line, so it is pi ds. No problem. Let me first draw the curve. That what kind of curve is this, and then we will solve it. So here we are given the curve cardioid. The cardioid here the cardioid is r is equal to a into 1 minus cos theta. This is the first one. Now the curve is of what kind? Let me just draw that. Now here the curve will be of what kind? If I put here theta 0, at 0 it is 0, because cos 0 is 1, 1 minus 1 0, and at pi it is minus 1, so minus 1 plus 2, 2, that is the point. It means in this case at 0 it is 0. This kind of curve will be obtained. Now it is at theta equal to 0. Okay, and this is about the initial line. This is initial line here. Let me take O point, and at this is twice a pi here, theta equal to pi here, and here it is 0 0, because at 0 if I substitute r equal to 0, 0 0 and 0, theta is 0, r is 0 in this case. Now this is the cardioid which is revolve about the initial line, this at theta equal to 0. So we have to revolve about this line. If I take P point here, and that is P point, if I take this is, let me take Pn, and this is Q here, and this is Q, and delta S is this arc length. Okay, and this is theta here. So we have to take this point from, this is r and r theta d theta. We will just calculate that in the same way as we took there. Okay, so we can take coordinates of this in polar equations as r cos theta, value of this, and r sin theta. Okay, so same way here cardioid is this. So what is the limit here? 0 to pi. We will take limits because this arc is revolve about this line. Now only 0 to pi limits will be there. Here solution, let me find out. Here dr upon d theta dr upon d theta is equal to a into minus cos theta is differentiated. Cos theta differentiation is minus sin theta, but minus plus, so it will be plus sin theta. It is sin theta here plus sin theta. That means dr d theta. What about, since ds upon d theta is equal to square root r square plus dr d theta whole square, therefore ds upon d theta is equal to square root r square is this value. This is a square into 1 minus cos theta whole square plus a square sin square theta. This dr d theta whole square. It will give us again. Here it is a I have taken outside from both. It is 1 minus 2 cos theta plus cos square theta plus sin square theta. Again this is a into, okay, this is sin square theta plus cos square theta is 1, so 1 plus 1 2. So under the square root 2 into 1 minus cos theta. Since sin square theta plus cos square theta is equal to 1, sin square theta plus cos square theta is equal to, so we are substituted here 1. This 1 plus 1 is 2. So 2 are taken common, so this 2 into 1 minus cos theta. But 1 minus cos theta is 2 into 2 sin square theta by 2. This is 1 minus cos theta is 2 sin square theta by 2. 1.2 theta angle. Therefore, this is nothing but 2 into sin theta by 2 will come out. So this is twice a sin half theta. Therefore, ds d theta equal to this value. Okay, we will use it here. Let me write here d theta is equal to here twice a sin 1.2 theta. This is the value of ds upon d theta. Okay, now let us find out what is the area then. Area of the surface, or required area of the surface generated. Therefore, the required area of the surface generated is equal to a is equal to, let me take, here limits are 0 to pi. 0 to pi, it is twice pi. Now y into ds. Now I cannot forget this y into ds. But in the previous one I first did in this way, but I'm sorry, because in there it was x into ds, but here it is y into ds, because this is y here point. Okay, this length is y, perpendicular is y. So it will work as a radius 2 pi r. Okay, this is a radius here. Now 2 pi r into ds. So this in this case y is radius, in that case x was radius. Now this is 2 pi, let me take outside. 0 to pi here, y is a into 1 minus cos theta into y is, I'm sorry, here I have to substitute. Let me put here 0 to pi, this is twice pi, and y is r sin theta, because y is equal to r sin theta we take, and x equal to r cos theta. This is the parametric form of this equation, or Cartesian form we take x equal to this and y equal to this. So this is r into this sin theta. This is sin theta here into this value twice a sin half theta into d theta. Finally, this is value of ds upon d theta. So we can write twice pi into r into sin theta into ds upon d theta into d theta. This we have written down twice pi as it is. Y is r sin theta, and ds upon d theta we can write into d theta. Ds upon d theta is twice is sin half theta, and r sin theta as it is. R is this, and twice pi are taken outside. Okay, now this is twice pi as it is. 0 to pi here. A square, a into a, we can take outside a square. Now this 1 minus cos theta is 2 sin square, 2 sin square 1.2 theta. This into sin theta is 2 sin theta by 2 into cos half theta. into sine half theta is already there, so this is into d theta. Why this sine theta is? Because we know that sine 2 theta, since by trigonometry this is 2 sine theta, trigonometric identity, this is into cos theta. So sine 2 theta is equal to 2 sine theta into cos theta. Therefore sine theta is equal to 2 sine theta by 2 into cos theta by 2. Angle is halved. That's the point here. So this we have used. Now sine 1.2 theta is this same, and 1 minus cos theta, we know that this is sine square theta. Since cos 2 theta is equal to 1 minus 2 sine square theta. So this 1 minus cos 2 theta equal to 2 sine square theta, or cos theta equal to 1 minus 2 sine square theta by 2. That 1 minus cos theta equal to 2 sine square theta by 2. This is there. 2 sine square theta by 2. Value of 1 minus cos theta. Now let me further summarize this. So let me write here. So it will give us now this 2 pi into 2 into 2. Okay. So 2 to the 4 to the 8. So this is 8 pi a square. Limits now 0 to pi. This is now sine half theta, sine half theta, sine half theta. There are 4. It is sine raised to power 4 half theta into cos half theta d theta. Now if I put 1.2 theta equal to something, then it can be solved by gamma function. Okay, this is half theta, okay, and sine 4 theta. Alright, now let us discuss further. Now it will give us, let me consider or putting 1.2 theta equal to, let me take t, or we can take phi, no problem at all. Therefore theta is equal to 2t, differentiating it with respect to t, differentiating it with respect to t, we get, what do we get here? This is d theta is equal to twice dt, simple, or d theta upon dt equal to 2, the dt taken to that side is d theta equal to twice dt. Put the limits here then, and put the limits here. When theta is pi, t equal to pi by 2. So at theta is equal to pi, t is equal to pi by 2. And at theta is equal to 0, t is also 0. So limits are this. Now this d theta is 2 dt. 2 dt, if I write 2 taken outside, this is 16 pi into a square, 0 to pi by 2 now. And this is sine raised power 4 t. Or we could take a d5. Okay, let me take t here, no problem. Cos t into dt now. Angle can be anything. Okay, it can be phi, or t can be the angle, x can be the angle, doesn't matter. Now we can apply now gamma function. Now by gamma function, we know that gamma function, since by gamma function, by using gamma function, what is the gamma function says in this case? 0 to pi by 2. It is sine raised power m theta into cos raised power n theta. This is m here into d theta is equal to gamma m plus 1 upon 2 gamma n plus 1 upon 2 divided by twice gamma m plus n plus 2 upon 2. This formula can be applied here because limits are 0 to pi by 2. Same. Okay, so this is 16 pi a square. Now this is 4 in place of m. In place of n we have 1. It is gamma 5 by 2 because 4 plus 1 upon 2 means 5 by 2 into gamma 1 only because this is 1 plus 1, n is 1, so n 1 plus 1 is 2, 2 upon 2 is 1, divided by twice gamma 4 plus 1, 5 plus 2, 7, 7 upon 2. Now we can resolve it further. 16 pi a square gamma 5 by 2, let me put as it is, this is 1 here, gamma 1 is 1 upon 2 into 7 by 2 gamma is 5 by 2 into gamma 5 by 2. Why? Since gamma n is equal to n minus 1 into gamma n minus 1. Try to understand 1 lesser than this, and we put this gamma n equal to gamma n minus 1 into gamma n minus 1. Similarly, 7 by 2 means 7 by 2 minus 1. It means 5 by 2. 5 by 2 into gamma 5 by 2. Gamma 5 by 2 cancel out. 1, 2 cancel out. Only 5 will be there. It is nothing but 16 pi a square upon 5. This is the answer here. Is it 16 or 32? Let me further solve, check it whether there. It was twice pi into that value. Okay, it may be the same answer. 16 by 5, 16 pi a square. That is the point here. Okay, but answer is coming 32 pi a square. What is that point? It means 2 pi. I just have mistaken here. Or ds upon d theta is this 2. Let me further check. This is 32 pi by 2. What is that 32 pi by 2? Let me just resume this. How it is 32 pi by 2. Okay, so area was given by us as area was 0 to pi limits, 0 to pi, and it was 2 pi into y into ds. That was there. Now 2 pi I have taken outside, 0 to pi, and it was r sine theta y is ds d theta was 2a into sine half theta into d theta. Okay, now r sine theta, r is there, r is this value, so this is twice pi. Let me just, I'm checking. R is a into 1 minus cos theta, so 2, okay, this 2, and this 2 I have taken outside. Let me take this 4 here, so now it has come as 4. Okay, now this is a square also I have taken, which is 1 minus into sine theta is there, into sine half theta into d theta. Now how many 1, 2 will come from this? 1, 2 will come from here, and then 1, 2, so 8 for the 32. Okay, this is 4 pi. This 2, this is 2 sine square theta by 2, and this is 2 sine theta by 2. Okay, into cos theta by 2, sin theta is, and this sine 1 theta. Okay, but when we assume this or half theta equal to t, then 2t, 2 dt will come, so 2 more will come, so 2 to the 4 to the 8, 8 for the 32. I'm sorry, answer is 32 here. So 1, 2 I just mistook here. This is 32 pi a square into under root this value. So this is 32 pi a square. I'm sorry. It's simple, just we can check it. We just rechecked. Answer is 32 pi a square upon pi 5. So 32 pi a square upon 5. The answer is this. Okay. So our minor mistake can change the answer. I'm sorry, I rechecked this. Answer is 32 pi a square upon 5. Now let us take question number 3. I'll take care that mistake will not occur. But let me take next question. Question number 3 now. What does it say? Question 3 says the arc of the cardioid. Arc of the cardioid, this is specified by this limit, is rotated about the line theta equal to 0. Okay, so theta equal to 0 here. This arc is revolving. We have to prove that the area of the surface generated is 4 by 5, 8 minus root 2 into pi a square. Let me check it. Question number 3 here. Here the cardioid is r is equal to a into 1 plus cos theta. Okay, this is first equation. The cardioid is here. The cardioid is this. Okay, and to prove here, if arc is revolved about initial line, then area generated is equal to 4 by 5. It is 8 minus root 2. Okay, root 2 into pi a square. This we have to prove here. This area A is equal to. Okay, to prove here. Now let us do it. Solution. Again, what kind of this curve is? This is cardioid by the first one type. It will be here. Let me take, this is like this, because at pi it will be 0. If I put here pi, cos pi is minus 1, so 1 minus 1 0, so r is 0 at theta equal to pi. Here it is theta equal to pi, so it is 0 0. Here it is twice a length will be, and this is twice a 0. Theta is 0 here. This is initial line. Let me take x here, this is O point, and here it is theta equal to pi by 2. No problem. So if I take P point, this is the arc here. Okay, now this arc, for this arc limits will be taken as 0 to this. Now this arc is revolved about it, because limits are given here, minus pi by 2 is less or equal to pi, theta is less or equal to pi by 2. So this limits now 0 to pi by 2. We have not to multiply by 2 because this arc is revolved about initial line. So only 0 to pi by 2 limits we will take. No half of that. Okay, that's the point here. Now let me talk about this with the question. So this is twice a 0. So here r is this, dr upon d theta. Let me find out. Differentiating first. Differentiating it or differentiating first. Let me write here with respect to theta. We get dr d theta is equal to a into minus sine theta, which is minus a sine theta. Dr d theta is, but ds d theta is equal to under root r square plus dr d theta here whole square. So this is r square is that value, a square into 1 plus cos theta whole square, plus this is a square into sine square theta, because square of this will be positive, a square sine square theta. Again we can take a common. Inside it will be 2 into, this I have done in the first question. Same value is here, 1 plus cos theta. So this is 1 plus 2 cos theta plus cos square theta. Cos square theta plus sine square theta is 1. So that 1 plus 1, 2, 2 plus 2 cos theta it will be. 2 we have taken common. This is 2a into cos theta by 2. But 1 plus cos theta will be 2 cos square theta by 2. 2 into 2, 4. So 4 can be taken outside. Now this is cos half theta. This we have done in the first question. This is value of ds d theta. So ds d theta, let me write here, is equal to twice a cos half theta angle. This is value of ds d theta. Okay. Now let us take further. Therefore, area in this case will be required area. Required area of the surface generated by revolving arc. Let me take here A, this is B, only arc AB. Arc AB about initial line, this about initial line, that is theta equal to 0 line. Theta equal to 0 line. So about this initial line, this is O, that we take here OX. OX line, this is P point we have taken. If I draw perpendicular, this is PQ, this is delta S here, and this is Y here. So again, limits here will be 0 to pi by 2, simple, 0 to pi by 2. Okay, and this is 2 pi into pi into ds. can be written as twice pi limits 0 to pi by 2. Pi by 2 only this 0 to pi by 2. This arc is revolved about initial line. This is 2 pi I have taken. Y is here. Y is r sin theta. This is r sin theta into ds d theta into d theta. We can write. Now r is this value. So let me put that value there. Okay, so that will be. Let me now write it here. ds d theta was ds d theta is equal to twice a into cos half theta. That we will use. So let me write here. Therefore, required area A is equal to twice pi 0 to pi by 2. R is here A into 1 plus cos theta into sin theta. This by into ds d theta is 2a cos half theta into d theta. This is the value. Therefore, let me now write it here. It is a 2 to the 4 here. So it is 4 pi a square 0 to pi by 2. This is 1 plus cos theta. Again 1 plus cos theta is 2 sin square theta by 2 cos square theta by 2. We can write it as 2 cos square theta by 2. It is 2 into cos square theta by 2. This 1 plus cos theta is sin theta is also 2 sin theta by 2 into cos theta by 2. We know about into cos 1.2 theta into d theta. This value 2 I have already taken. So this 2 and this 2 further 4 will come. It is 16 now. So 16 pi a square 0 to pi by 2. So now it is cos raised power. What is that? Cos 1, 2, 3, 4. So cos raised power 4 half theta. Cos raised power 4 half theta into sin power half theta. Sorry, 1.2 theta. Angle is half theta. This is half theta. 1.2 into d theta. Try to understand. One cos, second cos, and cos square. There are 4 power of cos 1.2 theta, and sin 1.2 is there. This 2 I have taken outside. So 16 pi a square it is. 16 pi a square it is. Now if I take minus pi by 2 to plus pi by 2, so this whole arc is to be revolved about. This is minus pi by 2 for this whole arc. We cannot say this because this is arc also. If I take this b to b, then it is minus pi by 2 to plus pi by 2. Let me take limits here minus pi by 2 to plus pi by 2 to plus pi by 2. Okay. Now integration of this can be done as okay, and if I write it as cos theta and t, if I substitute, then what it will be? So here it is limit is rotated about the line theta equal to 0. Sorry, 0 to pi. With what question? Third question. Theta 0. I'm sorry, why I have taken this? This arc, this whole arc will be there. 0 to pi we have to take here. I'm sorry, it is 0 to pi here. It is 0 to pi. What I'm talking about? The arc of the cardioid r equal to a into 1 cos theta is specified by this limit is rotated about the line. So this arc will be a revolve about the line. This theta equal to 1.2 pi by 2. So theta equal to 0. That means initial line that we have to take. There is an initial line here. 0 to pi by 2 we have taken no problem at all. The answer we have to take out, answer is given here. So we have to prove that it is 4 by 5, it is a 32, okay, it will be there. minus 8 by 2. So that is there. Now let me further solve it, and let me check it that what answer comes out to be. What is the answer which is coming out? Let me check it. So if I just put here half theta is something, it is that half theta up to now it is okay because they are not just parallel about. So let half theta equal to 5. Okay, let me take 5 or t, let me take, no problem. So theta equal to 2t here. Theta equal to 2t here. Therefore, or if I take cos 1.2 theta equal to something, let me take cos 1.2 theta equal to something, because that will not give us gamma function here, because pi by 2 limit is all, this is 0 to, I'm sorry, only arc is revolved also, it is 0 to pi by 2. This is 0 to pi by 2, I'm sorry. Now come to the point. So if I take cos 1.2 theta is equal to t, let me take. Okay, then minus sin theta into 1.2 d theta equal to dt, or sin 1.2 theta d theta is equal to minus 2 dt. This is the value here, minus sign. What are the limits here? Limits, when I put pi by 2, it is pi by 4 here. It is pi by 4. So sin cos pi by 4 is again 1.2. It is 1.2. So at theta is equal to pi by 2, t is equal to pi by 4. Try to understand. And at theta equal to 0, it is cos here. And at theta equal to 0, cos 0 is 1, so t is equal to 1. 1 is greater value than 1.2. Yes. So it is t equal to not pi by 4, it is 1.2. I'm sorry. What I'm writing here. I'm counting error. So t is equal to 1.2. I'm sorry. So let me put here. This is minus sign here. So 2 will again come with minus 32 pi a square divided, okay, not to divide by anything. It is now 2 I have taken outside. So this is 1 to 1 upon root 2. 1 to 1.2 limits. So this is t raised to power 4 into dt. Negative sign